Hello, hi everyone. Welcome to the Student the Brand. This is our Siva sir. Today we are going to discuss about electric current. CBSE Grade 10 Physics. Electric current. Let's start. Electric current. So electric current is nothing but the rate of flow of charge. The rate of flow of charge is called electric current. I equal to Q by T. The rate of flow of charge is called electric current. I equal to Q by T. Okay. So I equal to Q by T. SI unit of current is ampere. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of current is ampere. SI unit of time is SI unit of charge, coulomb. So here you can say this is a coulomb. And this one is second. Okay, SI unit of time is second. Now 1 ampere is defined as 1 coulomb of charge flowing through. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. Okay, so that is called electric current. I equal to Q by T. I equal to Q by T. Right? Yes. So here in the conductor, so there are number of charges are moving. We can't say only one electron is moving. We can't say only 2 electrons flowing. There are many charges are moving inside of the conductor. Many charges are moving in the conductor. So that's why it is called quantization of charge. That's why it is called quantization of charge. Charges are moving inside of the conductor. Charges are moving inside of the conductor. Okay, right? So that is quantization of charge. Q equal to plus or minus Ne. Q equal to plus or minus Ne. N is number of charges. N is number of charges are moving in the conductor. Okay, so N is the number of charges are moving in the conductor. Right? So on one electron, how much charge is present? On one electron, 1.6 into 10 power minus 19 coulomb. On one electron, 1.6 into 10 power minus 19 coulomb is present. In 1 coulomb, how many electrons are present? That's very important. On 1 electron, 1.6 into 10 power minus 19 coulomb. So that is a charge. In 1 coulomb, 1 by 1.6 into 10 power minus 19. Then if you take it up, then we'll get, so 1 by 1.6 into 10 power 19. 10 power 19. That is 1 coulomb. Okay, if you do this value, you'll get it. 1 coulomb, 0.625 into 10 power 18, 10 power 19. Same value, after dividing, you'll get this value. So after that, 1 coulomb, so 6.25 into 10 power 18 electrons. In 1 coulomb, 6.25 into 10 power 18 electrons are present. 10 power 18 electrons are present. Very, very important. Just check once. SI unit of current is ampere. SI unit of time. SI unit of current is ampere. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. Right? Now, so Q is a quantization of charge. What do you mean by quantization? So in the conductor, In the conductor, only one electron will not, if only one electron flows, we can't say current is flowing. Only two electrons flows, we can't say current is flowing. Only three electrons flows, we can't say current is flowing. There are many charges are moving in the conductor, then only we can say current is flowing. Yes or no? Many charges are moving, then only we can say current is flowing. So Q equal to plus or minus N. N is the number of charges. Number of charges are moving in the conductor. On one electrons, 1.6 into 10 power minus 19 coulomb. On one electron, 1.6 into 10 power minus 19 coulomb. In 1 coulomb, in 1 coulomb, in 1 coulomb, so in 1 coulomb, 6.25 into 10 power 18 electrons are present. 6.25 into 10 power 18 electrons are present. So, thoda aata. So, very little I can understand. Very little I can speak. So, not completely, not full-fledgedly. Okay. Alright, next one. So next one. So now we will discuss about electrical elements. Electrical elements. So after that we will discuss about electric circuit. After that we will discuss about electric circuit completed. After that Ohm's law. So we will discuss all those points. Okay, point number 1. Cell. This is the cell. So positive terminal, negative terminal. Second one is battery. So two or more cells together. So we can say like this. So positive terminal, negative terminal, cell, battery is here. Battery. And coming to the third one, open switch. This is a open switch. And next one, closed switch. Closed switch. This is a closed switch. And next one, fifth one, open switch. This is a open switch. Open switch and closed switch. Closed switch. Okay. Next one is resistor. Resistor. So resistor is a device. Resistor is a device which is used to oppose electric current in the circuit. A resistor is a device which is used to oppose the electric current in the circuit. Next one, rheostat. Rheostat. Okay, so sixth one, rheostat. Like this. Or we can say like this also. Rheostat. Okay, so resistor and rheostat. Next one we can go for seventh one is ammeter. Ammeter is a device which is used to measure the electric current in the circuit. Voltmeter is a device which is used to measure the potential difference. Ammeter and eighth one is voltmeter. Voltmeter is a device which is used to measure the potential difference. Okay. So next one, wire joining, wire crossing. Next one you can see. Ninth one, wire joining. Wire joining. This wire joining. 10th one is wire crossing. And 11th one is bulb. Okay. So these are electrical elements. Electrical elements. Okay. So you can see these are electrical elements like this. Electrical elements. I hope it is very clear. I hope it is very clear. Just check once. Check once. Cell, battery, cell, battery, open switch, closed switch, resistor, rheostat, ammeter, voltmeter, wire joining, wire crossing, and bulb. Here you can observe, resistor is a device. A resistor is a device which is used to oppose electric current in the circuit. Resistance is the phenomenon of opposing the electric current. Resistor is a device which is used to oppose the electric current in the circuit. Resistance is the phenomenon of opposing the electric current. Resistance is the phenomenon of opposing the electric current. So, Live Guru, thank you so much for supporting. So, resistance is the phenomenon of opposing the electric current. Okay. So, that's the point. And next one, resistor, resistance. And SI unit of resistance is ohm. SI unit of resistance is ohm. Okay. SI unit of resistance is ohm. Symbol, anyway, we will write. This is a symbol for resistance. And coming to the next one, rheostat. Rheostat is a device which is used to, rheostat is a device, rheostat is a device which is used to oppose the, which is used to regulate. Resistor is a device which is used to oppose the electric current. Rheostat is a device, rheostat is a device oh, thank you. Rheostat is a device rheostat is a device which is used to regulate the current. Rheostat is a device which is used to regulate the current without changing the voltage source. Rheostat is a device which is used to regulate the current without changing the voltage source. Okay? Yes. So thank you. So I am good. Thank you so much, Live Guru. Okay. So next. So resistor, rheostat, ammeter. Ammeter is a device which is used to measure the electric current. Ammeter is a device which is used to measure the electric current in the circuit. Voltmeter is a device which is used to measure the potential difference. I hope it is very clear. Right? Next one, wire joining, wire crossing, and bulb. Now we will discuss about rheostat is a device which is used to regulate the current without changing the voltage source. Okay. So best example, you can see the fan regulator. Automatically we can change the current without changing the device. Right? So that is the example. Now we can see electric circuit. Electric circuit. So now you can see here electric circuit. A closed and continuous path of an electric current. A closed and continuous path of an electric current is known as an electric circuit. Okay. So here I am considering this is a bulb. This is the bulb. So ammeter, and next one battery. So switch. So positive terminal, negative terminal, current is flowing like this. Okay, so the bulb is glowing. So like this you can say. Okay, so current is passing. Now point number one. Point number one. Conventional current and electric current. Conventional current and electric current. Conventional current. Conventional current and electric current. Second one is electric current. Electric current. Electric current. So here you can see, here you can observe. So the flow of positive charges is known as conventional current. The flow of positive charges is known as conventional current. Positive charges are moving from positive terminal to negative terminal, and the electrons are moving from negative terminal to positive terminal. And here you can observe conventional current. Oh, thank you so much. Aman Roy. Aman Roy. Thank you so much. So here you can see conventional current, the flow of positive charges, the flow of positive charges, the flow of positive charges. Okay. So here you can see, at least use super chart stickers. You can go with the sticker, then you can, okay. So type, then I can able to understand, because there are so many messages coming, right? That's why. Yeah, definitely I'll respond. Okay, so here you can see the flow of positive charges. Positive charges are moving from positive terminal to negative terminal. Electrons are moving from negative terminal to positive terminal. So be as a membership, you can go for membership, or you can use super stickers or super chat, and you can type, then I can able to recognize, because messages are continuously flowing, right? That's why I couldn't able to read, because if I'm continuously reading, it may be a disturbance. That's why use super chat or super thanks or membership. Be as a member. Then okay, now onwards we are going for practice sessions. Practice sessions also goes on. So if you are being member to the channel, then you'll get benefited. Definitely. So because very less time is there, use super chat, and super thanks. Okay, so please support to the channel by like, share and subscribe, and inform to your friends, ask your friends to join to the class. So if you like the content, if you like the channel, if you like my explanation, you can go for super chat, super thanks, and be a member to the channel. Definitely you'll get benefited. So early updated will be there. So everything. So for membership live also I will be soon. I will go and start. So be as a member. Membership live. So exclusively membership live will be going to start for membership. Those who taking membership, for them only I will start the live classes. So coming soon. Okay, be as a member and take a membership. Okay, then you'll get practice sessions more, right? Yes. So now you can see conventional current, right? Okay, the flow of positive charges is known as conventional current. The flow of electrons, positive charges are moving from positive terminal to negative terminal, electrons are moving from negative terminal to positive terminal. Conventional current, if you see, so conventional current is nothing but, so the positive charges are moving from high potential to low potential. That is, positive charges only moving from high potential to low potential. Okay, so positive charges. Electric current is nothing but the flow of electrons. So electrons are moving from low potential to high potential. Low potential to high potential. Okay, so conventional current, Positive charges are moving from positive terminal to negative terminal. Electrons are moving from negative terminal to positive terminal, right? So this is about conventional current and electric current. So before finding the protons, electrons, neutrons, already scientists were using the statement the flow of positive charges. So the direction of flow of positive charges is taken as direction of current. So that's why we are using continuously instead of changing all those things. Okay. So instead of that, we will use the same definition and same statement, that is a flow of positive charges. Positive charges direction is taken as conventional current, and electric current is nothing but a flow of electrons. Flow of electrons. I hope it is very clear, right? So that is about conventional current and electric current. So positive charges are moving from high potential to low potential, high potential to low potential, whereas electrons are moving from low potential to high potential, low potential to high potential. Okay, CS. And now we will discuss about electric circuit completed. Now Ohm's law we will discuss. Ohm's law. Ohm's law. Ohm's law. Ohm's law. So here you can see Ohm's law. So the potential difference across the ends of the given metallic conductor okay, very good. So potential difference is directly proportional to the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at a constant temperature. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional. V equal to IR. V is directly proportional to I. V equal to IR. V equal to IR. So I equal to V by R and R equal to V by I. V by I. Okay. So now materials required. What are the materials required? Materials required. Materials required. Materials required. Okay. First point is 4 cells 1.5 volts of each, and second one nichrome wire is an alloy of nichrome wire is an alloy of nickel chromium 0.5 meter length. And coming to third one, nichrome wire is an alloy of nickel chromium manganese and iron metal. So ammeter, and coming to the voltmeter, ammeter and voltmeter, and next one, fifth one, connecting wires. So switch, next one, connecting wires. Okay, so these are the materials required. Now, so circuit diagram okay, so I have to connect all those cells. So 1 2 3 4. So that I am connecting to the ammeter. So resistor, now resistor we have to connect. Resistor, switch, So voltmeter, here you can see, so voltmeter across it here. So current is passing like this. So positive terminal, negative terminal, positive terminal, negative terminal. Okay. So here you can observe procedure. What is the procedure to do that? Procedure. First you have to connect one cell and note down the reading of ammeter and voltmeter. First you have to connect one cell and note down the reading of ammeter and voltmeter. And connect to two cells. Again note down the reading of ammeter and voltmeter. And repeat the process for 3 and 4. Once again, first you have to connect one cell. Then note down the reading of ammeter and voltmeter. And connect to two cells. Then note down the reading of ammeter and voltmeter. And repeat the process for 3 and 4. And mention in the tabular form given below. So this is the tabular column. Serial number of cells, ammeter reading, voltmeter reading, V by I form. Serial number 1, 2, 3 and 4. Serial number, okay, so you have to take serial number. Number of cells. So ammeter reading current, voltmeter reading potential difference, V by I equal to R. 1, 2, 3, 4, 1, 2, 3, 4. Okay, so 4 cells. And draw the graph for VI. If you draw the graph for VI, the graph is linear. Okay, so linear is nothing but the conductors which obey Ohm's law, those are called ohmic conductors. For ohmic conductors, the graph is linear. For non-ohmic conductors, the graph is curved. For ohmic conductors, the graph is linear. For non-ohmic conductors, the graph is curved. Okay, check once here. So I am drawing like this. So V on y-axis, I on x-axis. Sorry, the graph is linear, right? So this is the graph. The graph is linear like this. And the graph for the graph is VA graph, V on y-axis, I on x-axis. The graph is curved. Okay. So ohmic conductors are nothing but the conductors which obey Ohm's law. Those are called ohmic conductors. The conductors which does not obey Ohm's law, those are called non-ohmic conductors. The conductors which obey Ohm's law, those are called ohmic conductors. The conductors which does not obey Ohm's law, those are called non-ohmic conductors. Okay, so let's start. So I hope it is very clear. So this is about materials required and Ohm's law. Let's start. So now we will discuss about resistance and resistivity. Resistance and resistivity. Resistance and resistivity. Resistivity. So resistance R is directly proportional to length of the conductor. So Hindi, so very little I know. So even for teaching also, I will teach only little in Hindi. So that's why I'm teaching English. Okay. So please understand. I will try. So in future I will try to learn Hindi and then teach in Hindi also. As of now I am teaching in English. So try to understand. So please cooperate and please encourage and please support. Okay. Thank you. So here R is directly proportional to length of the conductor. R is inversely proportional to area of the cross section. R is directly proportional to L by A. R is directly proportional to L by A, and R equal to rho into L by A. Now here you can see rho equal to RA by L. RA by L. So here you can observe rho equal to RA by L. Right? Yes. Understood? So now you can see here SI unit of resistance is ohm. Okay. So now you can see resistance is depends on temperature. Resistance depends on material of the conductor. Resistance depends on temperature. Resistance depends on material of the conductor. Coming to resistivity. So resistivity depends on temperature, and the second one, resistivity depends on material of the conductor. Resistivity depends on material of the conductor. Okay. Yes, that is the nature of the material. That is depends on material. Yeah, true, correct. Okay. So I hope it is very clear. Resistance and resistivity. Resistance, you can see, resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. R is directly proportional to L by A. R equal to rho into L by A. So resistance depends on temperature. Resistance depends on material of the conductor. And coming to resistivity generally formula I will tell. So it is very simple. In easy way I will tell the formula. So easy way, simple way I will tell the formula. See, resistivity is equal to R by L into A. R by L into A. So that is nothing but resistivity is equal to resistance of the conductor per unit length and unit cross sectional area. Very simple. By observing the formula, we can tell the definition. By observing the formula, we can tell the definition. Resistivity is equal to resistance of the conductor per unit length and unit cross sectional area. That's enough. Rho equal to R by A into A. Okay. And coming to the resistivity, SI unit is very important. Definitely it will come for so 2 marks. Derivation is very important. Derivation will come for 2 marks. How? So you have to write this formula. Derivation I'm explaining. Just check once here. So here you can check. So R rho equal to R A by L. We know SI unit of resistance is ohm. SI unit of resistance is ohm. SI unit of area is meter square. And SI unit of length is meter. Meter might get cancelled. Then you can see here resistivity is equal to ohm meter. This is the answer. So this question comes for 2 marks. Very important. Based on this one also. So based on this one also problems will come. So related to resistance also problem will be there. Related to resistivity also problem is there. And the derivation, based on the derivation, SI unit of resistivity, rho equal to ohm meter. So they will ask this one for 2 marks question. Derivation, you have to start from this onwards. R is directly proportional to A, R is directly proportional to L, R is inversely proportional to area of the cross section, R is directly proportional to L by R equal to rho into L by A, rho equal to RA by L, then ohm meter square by meter, ohm meter get cancelled, then rho equal to ohm meter. Okay, so this is the answer. Resistance and resistivity, right? Next, so we'll discuss about now we will discuss about resistors are connected in series combination. Resistors are connected in series combination. Please support my channel. Please share to everyone as much as possible, as many as possible. Inform to everyone, share to everyone, ask them to subscribe the channel. So that is the help I need from you all. Please support my channel. Please encourage the channel. Please share this channel to everyone. Okay, support the channel in all the ways. Okay, if you like the content, if you like the channel, if you like the explanation, you can go for super chat, super thanks, and be a member to the channel. So try to support in that way. So thank you so much, and inform to everyone. So thank you so much, Astunde. So thank you so much. So happy. So share to everyone. Share to everyone. Inform to all your friends. So ask them to join to the class. So the concern is for everyone. Actually, I had 10 years experience. Okay, in teaching career. I already worked in reputable institutions. Okay, worked. So then I started my own. This is my own. Okay. So try to support me. Try to encourage me. Try to share to everyone. So I had great 10 years experience. I worked in all the ways. So that's why. Hey, hi. Oh, great. So my students also joining. So my students are there. So they'll also joining. They'll also get to know, right? So that's why. So this is my own. So try to support me. Then I can able to do in a bigger manner. So do in a bigger manner. Okay. So I can reach to the more students. I can know what we can say. So I can make my subject to reach to everyone. To reach maximum students is my goal. To teach maximum number of students is my goal. So okay. So everyone will get benefited. So that's why I'm telling. So try to support in all the ways. So go for super thanks, super chat, and be a member, and inform to everyone. Subscribe my channel, share the videos to everyone. So 5.5k videos are available. Okay, so I'm trying my own. So I'm starting my own in YouTube. Okay, try to encourage me, try to support me. So I am doing my own. That's why. So initially it happens, initially we need to work so much hard, then only we will reach. So with your support, that too, with your support only I can able to reach maximum members. Overloading magnetic effects of electric current. Okay, actually short circuit. So Vishruth. So short circuit is nothing but the direct contact of live wire and neutral wire takes place. So when insulation may tore, sometimes insulation may tore, then the direct contact of live wire and neutral wire takes place. Then heavy amount of current will be drawn from the mains. And coming to the overloading, high voltage appliances on at a time, like washing machine, fridge, geyser, AC. Okay, this type of high voltage appliances, if you on at a time, then heavy amount of current will be drawn from the mains. Okay, so like that. Understood? Yes. Clear? So that's enough. So next. Okay, done. Come to the point. Next one, resistors are connected in series combination. Resistors are connected. Resistors are connected in series combination. So Ohm's law is completed. Next one, resistors are connected in series combination. We'll see resistors are connected in series combination. Series combination. Series combination. Series combination. Okay. So I'm taking one. So this is 1, 2, 3. That is connected to battery. Battery. So share to everyone, students. So share to everyone. Ask everyone to join to the class. So spread a word regarding the channel. So R1, R2 and R3. So V1, V2 and V3. R1, R2, R3. Okay, so here in the entire circuit, current is same. In the entire circuit, so entire circuit current is same. Okay, so IS equal to I1 equal to I2 equal to I3 equal to I, but potential difference is different. Potential difference is different. Then so we can take Vs equal to V1 plus V2 plus V3. Then we can write IRs equal to IR1 plus IR2 plus IR3. Okay, IR3. So I am taking I common. If I take I common, then we'll get I am taking common. So we can cancel I value R1 plus R2 plus R3. Then RS equal to R1 plus R2 plus R3. Rs equal to R1 plus R2 plus R3. Yeah, practice session, whenever practice session goes, that time I'll give. So now explanation, after explanation I'll give. Okay. So now Rs equal to, if n number of resistors are connected in, if n number of resistors are connected in parallel combination, sorry, series. Now we are discussing about series, right? If n number of resistors are connected in series combination, Rs equal to Nr. Rs equal to Nr. So based on circuit, also they will ask problem, circuit based problems. We will discuss about that also. Okay. So next resistors are connected in parallel combination. Now we will discuss about resistors are connected in parallel combination. So you can see now. Now you can see. So parallel combination, resistors are connected in parallel combination. Resistors are connected in parallel combination. Now you can observe. So I'm connecting now. So dear students, so please, I'm requesting all. So inform to everyone, share this link to everyone. So do like, share and subscribe to Student the Brand. Support my channel. Without your support, I can't able to reach maximum number of students. I can't take my subject to the maximum number of students. Try to support me. Try to inform to everyone. Okay, join to the class every day. So attend to the class. Attend to the class. Definitely. So we'll do great. Okay, so good content will be given in this live classes. Live classes will go on continuously. Okay, so live classes will go on continuously. So you can join to the live class and learn concept from me and inform to everyone and use super chat, super thanks and go for membership to the channel if you like the content, if you like the channel, if you like my explanation, and try to inform to everyone. I'm trying to inform to all the students. Once check the channel, so go and check the videos related to physics, how it is there, how much effort is kept behind of those videos. You will get to know. Then you can go with all the things. Okay, right. Now you can see here, I am taking resistors are connected in parallel combination. 1, 2, and next 3. So 3 resistors are connected in parallel combination. 3 resistors are connected in parallel combination. So ammeter, so battery. So you can check here. Positive terminal, negative terminal. So 3 resistors are connected in parallel combination. So R1, R2 and R3. So through R1, I1, through R2, I2, through R3, I3. So I'm connecting the voltmeter here. So I'm connecting the voltmeter. So here is the voltmeter. So you can check here. V voltmeter is here. Like this. So positive terminal, negative terminal, current is passing. So current is dividing into parts. through R1, I1, through R2, I2, through R3, I3. So in this case, you can observe potential difference is same, but current is different. So Vp equal to V1 equal to V2 equal to V3 equal to V. But current is different. Okay. So we know from Ohm's law V equal to IR. I equal to V by R. Right? V equal to IR, I equal to V by R. Okay. So now you can see Ip equal to I1 plus I2 plus I3. Ip equal to I1 plus I2 plus I3. So from this we can take V by Rp equal to V by R1 plus V by R2 plus V by R3. So from this I am taking V common. If I take V common, so actually voltmeter is used to measure the potential difference. Some difference must be there, high and low. Okay. So if you connect in series combination, if the current is passing entire the circuit same, so it won't show any reading. So there must be some difference from one point to another point across that only, across the resistor, across the conductor. So across the resistor, then only it will connect. So coming to ammeter, ammeter has fixed reading. If you connect ammeter in a parallel combination, it slightly gets heated because different appliances operate at different voltage. Yes or no? So that's the reason ammeter will not connect in parallel combination. Voltmeter is not connecting in series combination. Right? So that is our answer. I hope it is very clear. Now, next one. So 1 by Rp. So in this case, we am taking common 1 by R1 plus 1 by R2 plus 1 by R3. So VV get cancelled. VV get cancelled. So now 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. So if n number of resistors are connected in parallel combination, 1 by Rp equal to n by R, Rp equal to R by n. So 1 by Rp equal to n by R, 1 by Rp equal to n by R, Rp equal to R by n. If resistors are connected in parallel combination, the formula is 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. If n number of resistors are connected in parallel combination, so you can see here, so 1 by Rp equal to n by R, Rp equal to R by n, right? Yes. So this is about resistors are connected in parallel combination. Now, heating effect of electric current. Now we will discuss about heating effect of electric current. Let's start. Now, heating effect of electric current. The source of energy continuously gets dissipated entirely in the form of heat. The source of energy continuously gets dissipated entirely in the form of heat is called heating effect of electric current. Heating effect of electric current. So V equal to W by Q. V equal to W by Q. W equal to VQ, P equal to W by T, VQ by T, VQ by T. Okay. So V equal to W by Q, W equal to VQ, P equal to W by T, VQ by T. So we know Q by T is I. Q by T is I. Q by T is I. Now, so P equal to V into Q by T, that is nothing but VI. So then P equal to VI. So E into P equal to P into T. E equal to P into T. Okay. So that is nothing but, so H equal to VI into T. We know V equal to IR. V equal to IR. Okay. So now H equal to IR into I into T. Then we'll get I equal to H equal to I square RT. H equal to I square RT. Understood? So that's enough. So you can see heating effect of electric current. Heating effect of electric current is nothing but, so the source of energy continuously gets dissipated entirely in the form of heat. The source of energy continuously gets dissipated entirely in the form of heat. Okay. Now, so V equal to W by Q, W equal to VQ, W equal to VQ. So P equal to W by T. So W equal to VQ by T. Q by T is I. Q by T is I. Okay. And so P equal to W by T, VQ by T, Q by T is I. P equal to VI. P equal to VI. V equal to IR. V equal to IR. Understood? Now you can see, so E is the potential, so E is the energy given to the conductor, that is nothing but E equal to P into T. So that is H equal to VIT. H equal to VIT. V equal to IR. V equal to IR. Now, so H equal to IR into I into T, that is nothing but I square RT. I square RT. Heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to resistance. Heat produced in the conductor is directly proportional to time. Okay, so I hope it is very clear. So that is the heating effect of electric current is also known as Joule's law of heating. Heating effect of electric current is also known as Joule's law of heating. Okay, so I hope it is very clear. Next, so we'll discuss about so a few problems we'll do on this. Okay. So a few problems we'll do on this one. Let's start. We'll see. So electricity problems are there. So I'm expecting this question because every time I'm going to solve the problems, so this question is coming first in my mind. Maybe this question can be expected, so coming examination, so that much important. Let's see. So just make a mark this question expected, so keep it in the expected list. Okay, we'll solve this problem. A current of a current of 500 milliampere 500 milliampere flows in a series in a series circuit containing an electric lamp an electric lamp and a conductor and a conductor and a conductor of 10 ohm when connected when connected to 6 volts battery 6 volts battery. Find the resistance of the electric lamp. Find the resistance of the electric lamp. So if anyone knows the answer, let me know the answer. Okay. So check once. What is the answer? So I'll give some time. Let me know answer in the comment section. Okay. Okay, so 4 minutes time. Check the answer. So those who get the correct answer will see. So do like, share and subscribe. Okay, it's very simple one. So what we have to do is, see here, look at the problem. A current, so here current I is given. How much? I. So flows in a series circuit containing an electrical lamp. So electrical lamp and a conductor. So a conductor resistance is given. RC is given. RC is given, right? So this is the RL. Connected to 6 volts battery. What is its potential difference? Find the resistance of the electrical lamp. So I expecting question for 3 marks. I'm expecting question for 3 marks. Just focus on it. Now, so current is given, you have to write the values. So I'm writing this side. I equal to 500 milliampere. So point number 1. And coming to the next one, electrical lamp. So RL. RL they didn't give. Resistance, we have to find out the lamp only, right? So we need to find that answer. So potential and conductor is given. Conductor resistance RC is given how much? 10 ohm. And potential difference is given 6 volts. So whenever they'll give this type of questions, what you have to do, you must find out the units. You have to identify the units, whether they are in SI system or not. Okay. So here milliampere is given. 1 milliampere equal to 10 power minus 3 ampere. Then 500 into 10 power minus 3 how to write? 500 into 10 power minus 3 how to write? Then, so we know the formula. Which formula is suitable for the given data? V equal to IR. So we have to select the formula, because in physics there are many number of formulas are there. Okay, so especially particular concept, so we have to select the formula. So related to particular concept, related to particular problem, which formula is suitable, you need to select. You have to select. Okay, so here you can check. I am taking V equal to IR, right? So V already given how much? V already given 6. I is given how much? 500 into 1 milliampere into 10 power minus 3. So we can take 10 power minus 3 into. So here is the problem. Here they given 2. Resistance. So resistance of the lamp is given plus resistance of the conductor is given. Okay. So now you can check. So resistance of the lamp you have to find out. But resistance of the conductor how much? 10 ohm. So substitute in this. So 6 into, so you can take the value down. That is 500 into 10 power minus 3. Then you can take here RL, we have to find out, but RC is given, right? How much? What is the RC value? RC value is 10. RC value is 10. So those who are there in live, please do like, share and subscribe to Story in the Brand and inform your friends. So live classes will be going on for CBSE Grade-10 Physics. So practice sessions are going on. Try to inform to all your friends. Ask them to join to the class. And go for super thanks, super chat, and be a member to the channel. And here you can see, this is 6 into 10 power means 1000 I'm writing by 500. Then 2 zeros get cancelled. Then RL equal to 10. So here 5, so 60 by, how much? 60 by 5. Then we can take 5 12 here, right? Then RL plus 10. Then you can see RL how much? 12 minus 10. So RL equal to RL, so take 10 this side. So 12 minus 10. RL equal to 2 ohm. So resistance of the lamp. That's enough. That is the answer. So do like, share and subscribe to Story in the Brand. Okay, so live classes will be going on. Practice sessions are going on. Okay, inform your friends. Ask them to join to the class. So, okay, so RL is 2 ohm. Those who said the RL equal to 2 ohm, that is the correct answer. Okay, so we'll go to the next one more problem. One more problem. Okay, so let's start. This time I'll give simple problem. So try to solve it. I'll give simple problem. So this is also simple one only, but we need to understand. Okay, see the next one, next problem. So find the resistance. Question. Find the resistance. Find the resistance. Resistance of a conductor. So if the electric current, if electric current flowing, electric current flowing through it is it is 0.35 ampere when the potential difference across it is 1.4 volts. Okay, full stop. So try to do this question. So just check the answer. So I'll give time. So again 4 minutes time I'll give. 4 minutes time. So very simple, but just try it. I hope you'll get it. Right? Try this question. So yes, 4 ohm is correct. Very good. So many of the students they mentioned very nice. Good job. So very simple only. So V equal to IR. V equal to IR. So one more problem after this. Very good problem. I'll explain. Just check once. Here I am taking. So current is I. You have to mention, and the potential difference is V. So they are finding resistance. They are asking to find out resistance R. So V equal to IR. V equal to IR formula directly I am writing. So anyway, so first write I equal to 0.35 ampere. Potential difference is equal to 1.5 volts. Anyway, all are in SI units. So no problem. Now, so 1.5, sorry, 1.4 equal to 0.35 into R. R equal to 1.4 by 0.35. So multiply and divide with 100. Then you will get 140 by 35. So how many times it goes? So 4 times. So just check once. R equal to 4 ohm. You have to write the units. Okay, 4 ohm. Simply you can't write 4. Okay, just check once. So this is the answer. So one more question, very important question. So very useful. So I'll write, just check once. Let me know the answer. So this question is very useful. So this question very important. Try this question. Okay. Question is a 6 ohm resistance wire resistance wire is doubled on itself, doubled on itself. Very important question. Doubled on itself. So calculate the new resistance of the wire. New resistance of the wire. Okay. So very important. Very important. I hope it can be expected question. So make it 5 star. So that much important it is. Okay. So let me know the answer. Very important. Very important. Highly important. Highly important. Expected question. Okay, let me know the answer. So I'll give time. 4 minutes time again. Check once. Very important question. So actually it is very simple question. Why people are making like that? So very easy, right? So as I mentioned, you have to read the question twice, thrice. So until you get it, you have to read. Okay. Simply if you follow that, you will not get. See, they mention 6 ohm resistance of the wire. Okay. So normally I am taking this the right. Okay. So resistance of the wire is this the wire, that is 6 ohm. So originally 6 ohm. So this wire is doubled on itself. Doubled on itself. You have to understand, doubled on itself means it's like a folding on itself. So suppose you can see here, best example, I am taking this the wire. This the wire. Suppose you can take this the wire. So I hope you can able to see like this. Doubled on itself. It is folded like this. Then area is increases, length will decreases. Once again, this the wire. This the wire, right? So when it is doubled on itself, means it is folded like this. Then initially this is the area, so this area also added. So double the area. And the length, what about length? See the length. Length gets off. And the area increases double accurately. 1, 2. So exactly it is double. Because same wire only, right? Same wire only. Same wire only I am taking like this. Understood? That's enough. So you can see. So it is doubled on itself, right? Then A dash equal to 2A. L dash equal to L by 2. Understood or not? Check once. A dash equal to 2A. L dash equal to L by 2. Now the formula is R equal to R dash equal to, so rho into, so anyway rho is same only, right? So no changes. Metal is not changing. So same. Then L dash by A dash. Then R dash equal to, so rho into L dash how much? L by 2. And again A equal to 2A. Then you'll get, so R dash equal to rho into L by 4A. What is the original value? So R dash equal to, so 1 by 4 into rho into L by A. What is the rho into L by A? That is nothing but resistance only, right? Rho into L by A, that is nothing but 6 ohm. Substitute this value here. That is R dash equal to 1 by 4 into 6. That is R dash equal to 6 by 4, 3 by 2. So 2 3 ja, 2 3 ja. So R dash equal to 3 by 2, that is nothing but 1.5 ohm. So R dash equal to 1.5 ohm. That is the required. So calculate the new resistance. R dash equal to 1.5. That is the answer. Okay. Understood or not? Once again check here. So very simple, very easy. A 6 ohm resistance wire is doubled on itself. Doubled on itself means you can check here. So here you can see here. So it is doubled on itself like this. It is the wire. So this is the wire. When it is doubled on itself means it is like this. So area is exactly doubled. And the length is get off. Yes or no? So if you like the content, if you like the channel, please do like, share and subscribe to Student the Brand. Inform your friends, ask your friends to join to the class, that is required. So I need your support. With that I can teach. Okay, so with more energy. So please encourage me, support me by doing like, share and subscribe, and share to your friends. Ask your friends to join. If you like the content, you can go for super chat, super thanks, and be a member to the channel also. Right? So now you can see here. A 6 ohm resistance wire is doubled on itself. Calculate the new resistance of the wire. Okay. So very simple. So this is the first wire, 6 ohm resistance. That is nothing but R equal to rho into L by A. That is nothing but 6 ohm. Okay. So then, so new resistance, it is folded, right? So like this wire. So it is folded on it. A is A dash is 2A and L dash equal to L by 2. So we know the formula R dash equal to rho into L by. So why we are not changing rho? Because rho is same, because metal is not changing, right? So rho dash R dash equal to rho into L by R. L dash is L by 2, A dash equal to A. So R dash equal to rho into L by 4A. Then 1 by 4 into 6, that is nothing but rho into L by A. Then 3 by 2, so R dash equal to 3 by 2 is nothing but 1.5. Okay, so I hope it is clear. R dash equal to 1.5. This is the answer. If you like the content, if you like my explanation, please click on like button. So subscribe my channel and inform to everyone. Okay, yes. So let's start another question. I'll give one more question, try to solve it. Okay, check once. So this one more question related to circuit based. So I'll give circuit based. Okay, try to do that. So this is the question. So try to answer it. So okay, so now you can see here it is very simple. So three resistors A, B, C are connected in such a way that total resistance of combination is 3 ohm. Show the arrangement. We have to show the arrangement. So normally I am taking three resistors 1, 2 and 3. So that too 2 ohm resistors. 2 ohm, 2 ohm and 2 ohm. If I add all those three resistors, will you get? So 2 plus 2 plus 2, 6. And if you do in parallel also, 1 by 2 plus 1 by 2 plus 1 by 2, will you get? No, you won't get it. 2 plus 1 plus 1 plus 1, 3 by 2. So that is 1 by Rp. Rp equal to 2 by 3. So it is not possible. So wrong. This method also wrong. So you have to try for different method. Okay. So now you can see here. Now we can observe. The answer is, so you have to connect 2 in parallel combination and 1 in series combination. 2 ohm, 2 ohm, 2 ohm. Then you will get correct answer. Then you will get correct answer. So these two if you do, 1 by 2 plus 1 by 2, that is 1 by Rp. Then 2 plus 1 plus 1. Rp equal to 2 by 2, that is 1 ohm. Then the remaining if you do it, so 2, again 2. So 1 ohm and 2 ohm, then plus 2 plus 1 is 2 plus 1 is how much? 3 ohm. So that is the answer. Understood? The final answer is 3 ohm. Is it clear? Right. So that is the answer. I hope you got it. Next, we'll do one more problem. A total, so it's very easy, simple only. So just try this question. So those who are new to the channel, try to subscribe. Do like, share and subscribe to Student the Brand. Yeah, sure, definitely I'll take care. Thank you for So this is the question. Try to solve it. If you know the answer, you can let me know. So we'll see how much time we can able to do it. So here you can see a total number of electrons. So dear students, you can go and get some rest. Okay, so it's a time for sleeping. So my live class will go on so until some time. After that I will also end the live class. Just you can take rest. So here you can see given data. Given data. So after the live class anyway it is uploaded as a normal video, so that's what I'm doing. So you can take rest. So n is given 6 into 10 power 46 electrons flow through the current when the current is connected external power 20 seconds. Here time is given 20 seconds. Okay, and find the value of current. We have to find out the current. We have to find the current here. So here. So in the conductor. So normally we know I equal to Q by T. Q equal to NE by T. So we know E equal to 1.6 into 10 power minus 19 coulomb. Okay, so on a 1 electron, 1.6 into 10 power minus 19 coulomb. Right? So that's why. So I'm substituting here, you can see I equal to, so N is 6 into 10 for 46 into E equal to 1.6 10 power minus 19 by, so T equal to how much? 20 seconds. 20. Then if you solve this one, you will get the correct answer. Okay. So just try it. Let me know the answer. Okay. It will be easy only. Anyway, so you can remove the zeros. Here you can zero, here. So after removing all the zeros, you can multiply the value, you'll get the answer. So the final answer I'll write here. Just check once whether you are getting correct or not. The final answer is 4.8 into 10 power 26 ampere. This is the correct answer or not? Just check once later. Okay. So subscribe for more videos. Subscribe. Student the brand. Okay. So we'll see. One more question. Is it possible or not? Okay. So this is very simple one. We'll try this. It's very simple one. Ten power 27 or 10 power 28? 27 or 26? So next one. How much? How much? How much work is done? Work is done. Work is done in moving in moving, a charge of 3C across 2 points having a potential difference, having a potential difference potential difference is potential difference is 15 volts. Just let me know the answer. If you know the answer, just let me know. Okay, just check once. So correct answer is 45. So how? So charge Q is given 3C and potential difference is 15 volts. So V equal to W by Q, W equal to V into Q. So W equal to 15 into 3, so 45 joules. W equal to 45 joules is the correct answer. So subscribe for more videos, more practice. Subscribe. So very good. So do like, share and subscribe to Student Brand. Okay, thank you so much for joining and attending and listening my class. This is Shiva sir. So do like, share, and subscribe to Student the Brand. Share to your friends. Ask your friends to join to the class. We'll see you in the next class. So we'll see. Thank you.